Alright, so let's review real quick. Those of you here Wednesday, hopefully it'll be a good review. If you're not here, hopefully it'll be even better. Okay, so exponential models. So things that grow by multiplication. So much quicker than linear. So exponential, for linear models grow at a constant rate, so the change is the same all the time. Produces a straight line. Exponential grows at a rate that's being multiplied by some factor, and it starts off and then curves way up. Once it starts to build speed, it really takes off. So there's kind of two types. Continuous growth. Continuous growth happens every second of every day. It's something that is continuously happening, and that kind of introduces E. So E is just like pi. It's a number, 2.7 something, 1 blah 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 blah. So it's an irrational number, decimal that goes on forever, and it usually shows up when things are continuously growing or decaying. So your function here, this f of x, this is the end amount. That's how much we'll have when it's all said and done. A is your initial amount, that's what you start with. E is that irrational number. K is our rate of growth. It's usually kind of a percent. And T is time. So if it is continuously decaying, the function is the same except for your rate of growth will be negative. Okay, non-continuous growth, same thing. This is our output, this is our end result. A is your initial value, K is kind of your rate of growth, and T is time. But for continuous, if it's non-continuous growth, it happens at a specific moment. So I think the example problems, they have like interest, you're gaining interest, yearly interest, and the moment you gain interest would be the end of the 365 days, and that is the moment that you gain your interest. So it happens at a specific moment, specified moment. If it's decay, the function is the same. The difference is k, so k is the factor of growth. If k is 2, that means you're kind of like our penny problem. It's doubling every day or every year. So instead of times by 2, times by 2, times by 2, times by 2, how many ever days you work, you could write that as 2 to the 4th, or 2 to the day, how many ever days you work. So 2 would be our k, it's our factor, and anything greater than 1 represents growth. Now if we let k be 1/2, then that is something. Let's say I start off with $100, I divide by 2, divide by 2, divide by 2, divide by 2. So division will represent our decay, multiplication represents growth, and divide by 2, divide by 2, divide by 2, that's the same as timesing by 1/2. So when our k is smaller than 1 fraction, that's going to model decay. Okay, then we introduce this cool trick. So it's a way, kind of a quick mental math trick. The rule of 70, you use it to estimate. So it's not exact, but it will give you a really close approximation how long it takes for something to double. Okay, so investors use this a lot. So let's say, let's look at this example below. So you purchase an investment property for $215,000 in an area that has appreciated 7% each year for the past several years. So you want to dump 215 grand. The market's going up, and you want to calculate how long is it going to take for you to double your money. So this is only used for doubling. So the rule of 70 is this. You take 70 and you divide it by the percent. So divide it by 7. Do not change it to a decimal. So 70 divided by 7, that is going to be 10. So it is only going to take me something close, so it's just an estimate, something close to 10 years for me to double my money. So let's look at the problem. Supposing this trend continues, what will the value of your house be in 10 years? So we think the value is going to be something close to 430 grand. What's up? Alright, so let's work it out and find the exact value and see how close we are. Now this model, so these are all going to be exponential models because they all grow by multiplication. But this one's going to be, it's going to happen at a specific time at the end of each year. So we are drawn to this, the non-continuous. So the amount of money I end up with is going to be my initial times the k to some t. So here's what we're going to do. You're going to take 215 grand and you are going to times it by 7%. So you're going to times by 0.07. So if you do 215 grand times by 0.07, 215, that means the interest is going to be okay, so it's going to be 15 grand 50. But now I've got to take that money made, that 7%, and I've got to add it back to the 215,050. So here we go, 0. So now in year 2, I'm going to times this by 7%. So I'm going to find 7%, because now my house is not worth 215 anymore, it's worth 230. And $50. So I times that by 7%, add it back in. So this is, I'm timesing by 0.07, times by 0.07, times by 0.07, but it's going to be way tedious to take the interest and add it back to the total to find the new total. So here's really what we're going to do. Here's the shortcut. So my A is going to be 215 grand. And instead of timesing it by 7%, I'm going to times it by 100% plus the 7%. So I want my function, my model, to calculate the interest and add it back to the total for me. So instead of timesing by 7%, I'm going to times it by 100% and 7%. And I'm going to put, in for t, I'm going to put 10. So here we go, my A, that's 215. The K was kind of tricky. If I wanted to add it back in for me, I know my house is going to go up 107% each year. And then the T is going to be 10. So it's going to be 215,000 times 1.07. So change it to a decimal, put 10. Okay, now let's do that. Times 1.07 raised to the 10. Okay, there we go. And it is going to spit out 422,938 bucks. So after 10 years, we're going to have 422 grand. We used our rule of 70, and we thought maybe we'd be closer to 430. So you're 8 grand off. That's not too, well, actually you're probably only 7 grand off, because that's about 423 grand. So that's pretty close. That's close enough for an estimation to do real quick in your head. Okay, now logs. Logs and exponential functions go hand in hand, because logs undo exponents. So they are inverse, just like plus and minus. And this is what you got to be comfortable doing. If you have an exponential problem, so 2 raised to some power equals 8. If your variable is ever going to end up in the exponent, the only way to undo it is with a logarithm. So you have 2 to some power equals 8, and logs, it's not arithmetic, it's not plus minus times divide, it's something totally different. We're going to undo this get this variable by itself, so you're going to undo the 2. And the only way to undo the 2 is to morph it to a log. So a log kind of has 3 components. You got to know where to drop each piece. The base will always go here. So log in base 2. And the answer, so I know the answer's got to be 8. The answer goes here. Then your variable gets kicked out and you're solving for x. So if you type in your calculator log in base 2 of 8, it will equal x, which mental math tells us x has to be 3, because 2 to the 3rd power is going to spit out an 8. So this is what you got to be familiar with, going from an exponential equation to a logarithmic equation. And it's pretty easy to morph. You just got to know where to drop each of the components. But logs and exponents go totally hand in hand, because they inverse each other, they undo each other. Okay, let's do one more of these. You purchase a brand new car for 32 grand. Unlike real estate, vehicles depreciate in value each year, so they're a bad investment. Suppose your car is expected to depreciate 5% each year, which is kind of low. They depreciate more than 5%. What is the expected value after 5 years? Okay, so this one again is not continuous. It's going to happen at a specific moment. And so we're going to use y equals a times k to the t. So I'm going to take my 32 grand and I'm going to times it by 5%. So if you do 32 grand times 5%, what's up, Brooklyn? That is going to be 1,600 bucks. But now it's depreciating, so we got to take 32 grand minus 1,600. Find your new total. Then your new total, you got to times 5% of that and minus it. So it's going to be way tedious. So here's what we're going to do. Our function y equals a 32 grand. Now you're going to times it by the rate. So the factor is going to be 5%, but we are going to do 100% minus 5% each year. So we are going to times it by, how many years? We're going to go 5 years, so we're going to go 5 years. So 32 grand, we're going to take 95% of 32 grand each year for 5 years. And 95% is smaller than 1. 32 grand. Anytime your k is smaller than 1, that is decay. So this is 0.95. So 32 grand times 0.95. 32 grand times 0.95 for 5 years. So my car is going to have a value of 24 grand 761 bucks. Okay, so let me stop for a minute.